Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases. Welcome to episode 20. We will cover questions 96 to 100 in this episode. For questions 1 to 95, please refer to previous episodes of this series. Let's get started. Question number 96. As a web application, a corporation has built a new video game. The application is deployed in a 3-tier design using Amazon RDS for MySQL in a VPC. Multiple players will compete simultaneously online through the database layer. The makers of the game want to show a top 10 scoreboard in near real time and to enable players to pause and resume the game while retaining their existing scores. What action should a solution architect take to ensure that these criteria are met? So let's look at the keywords here. This is a video game scenario. That's the application built in a 3-tier design. And the database tier is Amazon RDS, and it's in VPC. This is a multiplayer game, and your expectation is that the players will be competing simultaneously online through the database layer. And the requirement is that we need to have a top 10 scoreboard in near real time. So it's a near real time requirement. And players should be able to pause and resume the game, retaining their existing scores. So this is a stateful system. What action should a solution architect take to ensure that these criteria are met? So let's look at the keywords here. So this is the example or scenario where we are building a new video game, and this is built using 3-tier design, and the database layer is Amazon RDS for MySQL. The game is expected to be a multiplayer game, and players will be playing and competing simultaneously online. And the key requirement here is that we need to show at any point in time top 10 scoreboards and in near real time. Players are expected to also pause and resume the game, so we need to retain their scores as well. So it's a requirement where you want a very fast caching mechanism where you can retain the scores and also build the top 10 scoreboard. So based on that, we'll analyze this problem. So let's go through the options and see which one are the obvious wrong ones. Let's go to option C. Now option C is saying, let's put CloudFront distribution in front of web application to cache the scoreboard in section of the application. Now CloudFront is a good solution when you have to globally distribute static pages or static images. But in this particular scenario, where we are talking about a fast-paced dynamic gaming situation where we want to store top 10 scores and count it fast, sort it fast, as well as expectation that players will be able to stop and pause and resume the game, and still it maintains the position in the game and their score. I don't think this is the correct solution. So CloudFront in this application where we have dynamic content and a fast-paced game where things would be changing quite frequently in terms of score and members' position, it's an incorrect option. And the second one, I think read replica. Again, read replicas are a good solution when you're trying to build and separate a dynamic transactional load from a reporting load and minimize the load on the transactional load. That's when it is useful. It's not definitely useful where you have to have a very performance solution for scoreboard sorting and computation of the score and the requirement around players pausing and resuming the game. So these two are wrong, and that leaves us with two options. Both the remaining option are involving cache, and that's what we hinted that for such an application, for such an fast-paced gaming application with simultaneous members and top 10 scoreboard in a near real time, you need to have some sort of caching solution that can go with your Amazon RDS. Now, both the solutions, Elastic Cache, Memcache, and Redis Cluster, both goes well with Amazon RDS. But I would like to find the differentiating factor here. I'll take you to an example from AWS, and that would make our choice clear between A and B. So this is an article from AWS documentation, and this is an example of building a real-time gaming leaderboard with Amazon Elastic Cache Redis. This is exactly what our scenario is. We want a real-time gaming leaderboard, and additionally, obviously, we had the option of we also have a requirement of members storing their position and pausing and resuming. But if you go through this, and you will get the link for this in video description, you will be able to understand it better. But I would like to bring your focus to the caching part. And if you zoom in on the caching part of this, which is on the right hand side, and go through the Elastic Cache section, you will be able to figure out which out of Elastic Cache Redis and Elastic Cache Memcache is the correct answer. I'd like to zoom in for you that one of the data structure needed for such an application is something called as sorted sets. And sorted sets contains the list of members with associated scores. Although set members are unique, score values are permitted to repeat. Scores are used to rank the list in ascending order. One key difference between sorted sets and relational databases is that the tool sorts the list during the insert or update operation. Sorted sets automatically position the item in the right order. Because of this pre-sorting, queries run significantly faster, and this is the main difference. You can quickly and efficiently query the middle of the list or get the rank of a specific member. Sorted set find the specific ranking logarithmically proportional to the number of members. So this is the data structure that you need, and this particular data structure is available in Redis. So that is why Redis is the right choice for this based on the data structure needed for such gaming application. And that's what is going to give us our answer. Hence, we are ruling out Memcache because Memcache doesn't have the right data structure that is needed for storing and manipulating ranked scores leaderboards in near real time. So option A is the wrong answer. Option B is the correct answer. And we saw exactly why based on the article from AWS documentation that this is the correct answer. But we will do a deeper dive. So the first one is obviously caching. Redis can cache top 10 scores, which is a requirement, and it will reduce the load on the main MySQL database because caching is going to provide the near real-time updates for the leaderboard. The second one, which is the differentiating factor between Memcache and Redis, is the sorted set. Redis supports sorted sets, which is ideal for storing and manipulating ranked data like scores. This allows efficient retrieval of the top 10 scores, and this was the killer requirement and the feature from Redis that supports this requirement. And the last one is around, resuming and pausing persistence. So Redis can be configured to persist the data, ensuring that scores are saved even if the Redis cluster restarts. So this is another key. Even if Redis cluster restarts, you can choose to save the scores, and when players are coming back in the game, the score will be read from the Redis cluster, and those scores will be retained. So that's the overall discussion on this solution. That's it on this particular question. Let's move on to the next question. Question number 97. A business wishes to migrate its on-prem network attached storage to Amazon Web Services, AWS. The corporation wishes to make the data accessible to any Linux instance inside its VPC and to guarantee that change to the data store are immediately synced across all instances that use it. The bulk of data is viewed infrequently, whereas certain files are read concurrently by numerous people. Which option satisfies these criteria and is the most cost effective? Let's look at the keywords. There are a lot of keywords here. So it's a migration scenario. Business wants to migrate its on-prem network attached storage, NAS storage to AWS. And these are Linux instances inside the VPC, and we would like data to be immediately synced. And bulk of this data is viewed very infrequently. So that's another requirement. But when people view the data, number of people concurrently. So concurrent access is a requirement, and we need a cost-effective solution. And what we have in terms of option, which are obvious wrong options, and what is the correct one. Now, I think the key requirement here is the concurrent access and the file access. And based on that, I feel the answer will be definitely an Amazon EFS file system. So option A and B are going to be wrong, but let's look at those one by one. So option A says let's use Elastic Block Store snapshot containing the data and share it with the users within the VPC. Actually, EBS obviously is not suitable because they're block level storage devices that can only be attached to say a single EC2 instance. And our key requirement here is shared access. We want a number of people to access the data concurrently, and this is not going to be fulfilled using option A. So that's wrong. The second option, which is wrong, which is option B, it says let's create Amazon S3 bucket that has a lifecycle policy set to transition data to S3 infrequent access after appropriate number of days. Now it's basically catering to the bulk data is viewed infrequently requirement, which is all right, but it can be cost effective just from an infrequent access data perspective, but it is obviously not catering to the shared file system functionality and the low latency that we need when access is made. So it only caters to one requirement. So S3 bucket and moving to infrequent access storage type is not a correct solution. So option B is wrong. Then we have two options left, which both involve Amazon Elastic File System. So answer is one of these two. When you use EFS, obviously it's going to cater to concurrent file access. So that requirement is met. However, what we also want is we want to also cater to infrequent usage and making it cost effective in that scenario. So let's look at option D. Option D is let's create an Amazon Elastic file system within the VPC, set the lifecycle policy to transition the data to EFS infrequent access after the appropriate number of days. Now, this is not really effective according to me because the key requirement is the concurrent access, and whenever frequently accessed data is files are accessed, you need to provide high performance. So option D, according to me, doesn't satisfy that criteria. Whereas if you go to option C is using EFS file system, and it is setting throughput mode to provision and to the required amount of IOPS to support concurrent usage. So that is what is the key requirement here. So correct answer for this particular question is option C, usage of EFS file system and setting the throughput mode to provision and to the required amount of IOPS. Let's do a deeper dive on the answer that we have selected here. So the first requirement is about shared file system. So EFS is a fully managed cloud file system that can be mounted on EC2 instance within a VPC. So that requirement is met. Done. Option 2, we need immediate data sync. That was the second requirement. EFS provides low latency file operations, ensuring that the changes to the data store are immediately synced. So that requirement is also clearly met. Then came the differentiator fact between option C and D, which was the provision throughput mode. By setting the throughput mode to provision, you can specify the required amount of IOPS to support concurrent file access. So concurrent file access is an important feature, which is why we went for option C. And the last one is cost effectiveness for mixed access pattern, where you have infrequently accessed and frequently accessed data. So for the data that is viewed infrequently, the default storage class EFS standard is cost effective. For infrequently accessed file, the provision throughput mode ensures high performance at a reasonable cost. So this solution basically caters to both type of accesses, and it's a cost-effective solution for that. Hence, we have ruled out option D and we went with option C. So that's everything on this particular question. Let's move to the next question. Question number 98. A business hosts a web service on Amazon EC2 instance that are routed via an application load balancer. The instances are distributed across two availability zones through an Amazon EC2 AHG group. At all times, the corporation requires minimum of 4 instances to achieve the needed SLA requirement while keeping expenses low. How can the organization maintain compliance with the SLA if an availability zone fails? So the keywords here are that it's an Amazon EC2 auto scaling group problem. We have a minimum requirement that at any point in time, we want 4 instances. That's the keyword here. Right now, there are 2 availability zones used, and we have 4 options here to understand what should be the correct answer. So this is a very simple problem. They are saying is we want 4 instances at any point in time if one availability zone fail. You can use 2 availability zone, 3 availability zone, doesn't matter. In an ideal scenario, what I would do is I'll have 3 availability zones, and each of them I will have 4 instances, which means I have redundancy across 3 zones, which is the highest availability I can get. So even if one availability zone fails, we have the current availability zone, which is in action with 4 instances. And obviously there is a backup of second availability zone. Even if the second one fails, then you have your third availability zone. And in each of them, you have 4 instances. So this is one configuration, or the other configuration will be I'll only use 2 availability zones. And in each of them, there are 4 instances. Again, the number of instances that are needed, that needs to be in a single availability zone. So I can have 2 availability zones and 4 instances in each of them. My redundancy is down to only 2 zones. So if one zone fails, I do have second one. But if both the zones fail, then I don't have any redundancy. But that's a redundancy part of the solution. And if we have to choose between these two options with the cost effectiveness aspect as well, then obviously 2 availability zones with each having 4 instances will work. So that's the answer. And you can see that answer in option D, which is auto scaling group to use 8 servers across 2 availability zones, split as 4 each in each availability zone. So that's our answer, but let's go and see why other options are incorrect. So option A says let's add a target scaling policy with a short cooldown period. Now, target scaling policy can dynamically adjust the instance count based on the traffic. You can say, I have this target and here is a traffic metric, etc., and then adjust the AC2 instances. But it won't react fast enough if the zone fails. And that's what, the question requirement is. Also, short cooldown period might lead to excessive scaling activity. So this is not the correct answer. The next one, which is incorrect, is option B. It says, let's change auto scaling launch configuration to use larger instance type. Larger instance types is most likely the most incorrect option in case of AWS scenario, because they don't want you to vertically scale an instance. So this might just give processing power per instance, but it's not going to solve the issue of if a complete availability zone fails. However powerful the instance may be, if the zone fails, all your powerful instances are gone. So that's not a useful one. Then we have two options left, C and D. They are playing with the number of availability zones and number of servers. And now option C, if you look at, it says let's use 6 servers across 3 zones. Now that means you will have uh, two instances in each zone. You do have 3 availability zones. So that's giving you a very high availability, but you're not meeting your SLA anytime. You will always have in a particular availability zone for your usage 2 instances, and that doesn't meet the requirement we have, and hence our option that is correct is option D, which is using autoscaling group to use 8 servers across 2 availability zones. If the cost was not a problem and we needed even one more level of redundancy, then an option which says, okay, let's use 12 servers across 3 availability zone would have been a better answer, because that provides higher level of redundancy in terms of number of zones. 3 zones is better than 2 zones. And but obviously that comes at the cost that you will have 12 servers. But I think if the cost is not an issue, you still have requirement of SLA. I would create a solution which involves 12 servers across 3 zones, but that is not an option here. So from the given option, the best answer is option D, 8 servers across 2 AZs. Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you've not already done it. Thank you. Question number 99. Business has a bucket of Amazon S3 that includes mission critical data. The firm wishes to safeguard this data against inadvertent deletion. The data should remain available and the user should be able to erase it on purpose. Which action should a solution architect use in conjunction to achieve this? And we have to select 2 options. So what is the scenario here? It's a scenario of S3 storage data type, and we are looking at certain features of S3 storage data type that would allow us for stopping user from accidentally deleting the data. If you want to purposely delete something, that's fine, but it should stop accidental deletion. And there is a very good feature in S3, which is called versioning. So that versioning feature will ensure that when you delete something, another version of the object is created. You accidentally deleted something. Then what you need to just do is you have to go back and go to the version you want to recover. So this feature is excellent because if whenever you delete something, the data is not actually deleted. What it does is it does another copy, another version of that data. So you have multiple versions of a particular data structure. And if you want to undelete something, you basically go to a previous version. It's like version control on code. It's similar concept on the data. So that's definitely one of the solution. And the other one that would be useful in this case, which is, if there is an accidental deletion, let's put some safeguards against it. So do some multi-factor authentication. So that gives a second opportunity where you are adding a security layer for preventing the accidental deletion. So I think those are the 2 answers, but let's see what are the incorrect options and why. So option C, according to me, creating a bucket policy on S3 bucket. This is not going to help because you can create a bucket policies for not deleting something by a particular user or a group, but this will prevent all deletion. This is not going to prevent accidental deletions. So this is not possible because if you go back to the question, the requirement says we don't want accidental deletion. But if somebody wants to really delete something and if they're authorized, that should be possible. So option C stops everything. So that's not correct. The next one wrong is enabling of default encryption. In fact, this is the first incorrect answer according to me, because encryption protects the data at rest, but it does nothing if you accidentally delete it. It is protection that, whatever data you have, if it's gone to wrong hands, they won't be able to decode it because it's encrypted, but deletion is still possible. So option D is wrong. And the third one is option E. It says, let's create a lifecycle policy for the objects in S3 buckets. Now, lifecycle policies automate actions like deletion based on a specific criteria. While useful, this is for managing data lifecycle. It could lead to deletion, accidental deletion, if not configured carefully. So this is not the correct answer. Lifecycle policy basically moves objects from, say, one type of storage to another type of S3 storage. You can make copies, but this is not the right solution for accidental deletion. S3 has a built-in feature called versioning, and that is best solution if you want to stop accidental deletion and if you want to come back to a copy of an object that was accidentally updated, modified, etc. So these two are the correct answers, option A and option B. If you want to stop accidental deletion, use versioning to recover the file. And obviously, if you want to stop it at its tracks, then use multi-factor authentication so that you add an extra layer of security to prevent the accidental deletion itself. So these are the two things I would do. That's everything on this question. Let's move on to the next question. Question number 100. A recent review of company's IT spending demonstrate the critical necessity of lowering backup costs. The chief information officer of the organization want to simplify the on-premises backup architecture and cut expenses by phasing out physical backup tapes. The company's current investment on on-premises backup system and procedure must be protected. What recommendation should a solution architect make? So the keywords here are that, company wants to lower the backup cost and they want to simplify the architecture and cut the expenses by phasing out the physical backup tapes. And tape is a keyword here. The company's current investment in on-premises backup system and procedure must also be protected. So if you are storing backups in tapes now, you want a solution in AWS which stores backups in tapes. And that's the keyword here. And if you look through the options, you can see option B and C, usage of EFS. I don't think those are correct answers. If at all there is anything correct, I think that's related to AWS storage gateway. And if you look at storage gateway and different types of storage gateway, and I'll refer you to a documentation from AWS. So this is different types of storage gateway, file gateway, FSX gateway, which is a Windows file system. You have volume gateway and you have tape gateway. So you can see within AWS storage gateway family, you do have a gateway solution, which is specifically created for tape gateway. And that uses SCSI virtual tape library interface. And that's the solution. So if you need an answer for the question, then that has to be related to tape gateway. Now, what they have done is they have not clearly said tape gateway, but obviously they have mentioned the SCSI virtual tape library, which is what the tape gateway uses. So option D is your tape gateway, and that's the answer. But let's go through other options and let's find the reasoning why those are not correct to be 100% sure. Option A is not suitable because it is file storage and it cannot be used for storing tape data backup. And obviously we want to make sure that our solution is similar in terms of what we have in on-prem. So we want to carry on with storing the backup in tapes. The only difference we want is we want to put it in AWS. So option A is wrong. Option B and C both are wrong because it is using EFS file storage and both of these options do not provide any tape storage functionality or a virtual tape library functionality. So option B and C are wrong. We did discuss that in the beginning of the solution discussion itself. And that leaves us with final answer, which is option D. Option D is the correct answer for storing tape backups in case of AWS storage solutions. So this is our answer. And if you like, you can read a bit more in detail about tape gateways. Seen that FAQ page where we did talk about different types of tape gateways. So that's our answer. And that's everything on this question. That completes 100 questions on this series, Solution Architect Associate. I believe this was the last question of this episode. I'll see you in the next episode of this series soon. Thank you. This is Exam Tricks and Tips. You're watching the AWS Solution Architect Associate question series. See you in the next episode. Thanks for watching.